So when we go to look at the relative frequency histogram on the next page, we're just setting it up with pretty much the same parameters, you know, some slight differences. Oh, that's a triangle for some reason. I don't know why. All right, so my relative frequency values I have in L3, the largest value that I have there is 0.5-ish. So at least I know, you know, in terms of the scale. I'm going to do the break mark thing again. I'm going to set up my intervals the same way I did before. Now, this stuff is not complicated. Really, the only thing that you should be intently focused on is all the little minute details that people have typically neglected in the past, right? These are the things that if you're going to forget something, you'll forget and you'll lose credit, and you'll have the big idea down, but you'll lose credit on the little tiny details. So you gotta be careful about stuff like that. So 40 to less than 50. Oop, I forgot the to part. To less than 50. 40 to less than, oh, sorry, this is relative. So 50 to less than 60. So same intervals. And again, these are ages. I'm fine with RF as the abbreviation for relative frequency. Now, these relative frequencies are decimal values that max out at about 0.55. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got 10 to play with here. So I don't want to go by fives. So maybe I'll go by tens. So 0.1, 0.2, 0.3, 0.4, 0.5. And then we'll just eyeball it. All right, 0.2 is easy. That you don't need to eyeball. 0.55-ish. It should be the same picture, roughly. All right, so 0.22-ish. And then 0.02, so a smidge. All right, we can put the values in. I find it easier to put the fractions in because I don't have to worry about decimals. So 1/5, 5/9, 2/9, and then 1/45. There's no requirement that you simplify fractions really in this entire course. So if you wanted to, for your relative frequencies, you could actually just write it as 9/45, 25/45, 10/45, and 1/45 and be perfectly correct. All right, so no need to bother yourself with simplifying fractions. But since the calculator did it, I was going to take advantage of that information. All right, so stat edit. Now I'm going to get my cumulative values. All right, so my intervals set up the same way, except just slightly different on the low end. So 40 to less than 50. 40 to less than 60. 40 to less than 70. And then 40 to less than 80. So cumulative ages is going to be your label for the horizontal axis, and CF is going to be the label for the vertical axis. All right. Now this maxes out at 45. I have 10 horizontal lines to work with, so I'll just go by fives. 20, 25, 30, 35, 40, 45. 15, 10, 5, touchdown. All right. So 9, 34, 44, a little off there. And then 45. Putting the numbers in because my shaky handwriting doesn't allow for me to do such a hot job. So put the numbers in so the numbers trump the heights themselves. I forgot to put my axes in, so I'll just chuck those in. Right, meow. Put some arrows on those bad boys. Meh and meh. And there's your cumulative frequency histogram. So cumulative frequency histograms never decrease. They'll either always increase or remain the same in height, but they'll never decrease. All right. So there's never a decumulation. It's always accumulation. All right. So that's how you tackle all those different types of histograms. Now, if you're already given numerical intervals, manipulating your graphs so that you could actually have, manipulating your settings so that you could actually have all three of these graphs is not overly difficult. But the thing is that the technique involves just single numerical values in your X column. All right. So instead of saying like 40 to less than 50, it would be like just 40 or just 50, things like that. So this is not the best example to go over that concept, but when we come up with a nice example, I'll make sure to go over that. All right. So then we come to the idea of percentiles and quartiles. All right. Fortunately, the calculator pretty much, if you're given raw sets of data, the calculator will pretty much give you all this. All right. So, but sometimes it doesn't, because you're not given a raw set of data, so you can't just plug some stuff in the calculator. All right. So if you're trying to find a percentile corresponding to a certain score, we're always looking for the number of scores that are less than a particular value. All right. So less than specifically, not less than or equal, so we don't actually include the value. All right. There's different schools of thought for percentile, and some rules actually have you include the value. All right, but not the good rule. The good rule excludes the value, because a percentile rank is talking about the percentage of people that you beat, not the percentage of people that you tied with. All right, so we don't care about who's on par with you, we care about who's below you. Percentiles are often used when reporting academic scores such as SAT scores. Let's say you got a 620 on the math portion of the SAT. It might also indicate that you're in the 78th percentile. That means that you scored better than 78% of all students taking that particular SAT. All right. So we're looking for the percentile rank for the age of Kennedy. All right. So we've got to go back in time here. All right. So one individual out of the 45 multiplied by 100 and rounded. So 1 out of 4, let me get that out of here. 1 out of 45 times 100. We actually had this value from something else. Rounded. So this is what the decimal value would be, but that would correspond to, we always round it appropriately. It would be the second percentile. All right, so not too much, just a smidge of percentile below. Okay. Now, if you think about the process that we followed here, we took the number of values below a particular score, then we divided by the number in total, and then we multiplied by 100. All right, so we're just going to do the exact opposite now. We're going to take the the percentile. We're going to divide it by 100. That's going to give us 0.6. Then we're going to, instead of divide by the total number of values in the set, we're going to multiply it by the total number of values in the set. And that gives us 27 even. All right. So then what we have here is a little bit of an issue, because what we're looking for, and there's really a couple of different ways we can handle this. One is, in order for us to really do this correctly, we'd have to account for the fact that we, in part of this process, rounded that 2.2 to become a 2. But then that creates the issue of, okay, so how do we unround 60? Right? If we were to unround 60, it could be anywhere between 59.5 and 60, well, 59.5 and 60.49 repeated, right? So it's going to give you around 1 unit of wiggle room, all right? So what we do to account for that 1 extra unit of wiggle room is we include the next value up, all right? So we're going to say the 27th and the 28th value. All right? It creates wiggle room. Wiggle room due to the unrounding issue. The other way to think about it would be, and maybe this would make more sense because wiggle room is, I don't know if you consider that a math term. I consider it a perfectly legitimate math term, right? I say wiggle room, you might say margin for error, or margin of error. But it means the same thing. This is just a common vernacular way of saying it, perhaps. All right? The other way of thinking about it would be to say, wait a minute. We were counting the number of values below a certain score in order to find its percentile rank. If I were to go to the 27th value and just call that my final answer, what would end up happening if I were to go the other way? If I find that 27th value, if I were to then go the other way to check it, I would be counting the number of values below 27, which is 26 values. I'd be shorting myself 1 value. So we go up 1 additional value so that we're guaranteeing that the 27th value would be included in the set when you go through the checking process for finding the percentile rank. All right? So most of the time, those 2 explanations get the job done. If you don't like either of them, I'll try to make up something that satisfies you. It probably won't be true, but I'll come up with something that'll let you sleep at night. All right, but both of those are mathematically accurate ways of describing why we go the extra value up. All right, anything else would have to actually, by definition, be a lie. But sometimes, a well-placed lie can get the job done. All right, as opposed to, it's a rule, just study it. All right, because sometimes we don't want that one either. All right, so now I need the 27, 28 values. All right, well, the data is in ascending order, right? It was all jumbled up? Yeah, okay, so let's make it in ascending order. So in my stat editor, I have all my information in L1. I really don't need anything else, so let me just get rid of all that nonsense. All right, so instead of trying to eyeball increasing values, what we're gonna do is hit stat and select sort A. On L1, and I recommend you store it into L2. In this case, it's not going to make a big difference because we don't need the data set in jumbled order. But there are some situations where you actually need the data in its original form as well as in ordered form. So what I recommend you get in the habit of doing, just so you don't end up, kicking yourself later on, is sort L1, and then store into L2. You know what? I got a better idea. You know, because people, oftentimes they forget where the store key is in the middle of a test. There's not much I can do about that. I'll give you a better strat. It's something that you're more likely to remember. Go on to L2, hit enter, and just type L1. That'll repeat the list L1 into L2, and then just sort L2. Sort ascending L2. This way you don't have, it's grounded in stuff that you're already more likely to remember. And so you don't have to worry about, oh, where's that store key? Well, how does that store key work again? This is going to work for you. All right, so stat edit. Now it's in all of the data is in ascending order. Now I'm looking for the 27 to 28 values. Now you can see the list function has a counter. So it tells me what the first entry, third entry, I don't have to count them. I just scroll down, keep scrolling until I get to the 20, until it says 27, 28 on the bottom here. So both 56, which is beautiful. Because that means that the amount of work I have to do is minimal. All right, so the 56th value, the 27th value is 56 and the 28th value is 56. And what do you think I'm doing with these two numbers? Averaging them. Just like we would if it were a median. 56 is the 60th percentile.
If you had like a giant data set that would take forever to scroll through, is there a way to just like type it in and make it go to that value on L2?
Not that I know of. But, hold on, let me just do this. If you do, let me see here. Oh, that used to work. Oh wait, alpha down. It goes screen by screen instead of one by one. So it's something. You know. So 56 is the 60th percentile. Yeah, it's one of those things, like the calculator, I mean, it's got a lot of good uses for us, but it does fall short in the fact that it's still a calculator. You know, Excel has the power of a computer behind it, and all of Microsoft, so like your shortcut keys, like Control F, for example, you could find. So if you needed to get to the 60th value, you could just Control F, type in 60, and it'll jump you right there, but unfortunately, this calculator does not, and I don't foresee a situation where it will ever have these functions, so it sucks, but it is what it is, as Mr. McCallie would say. So, Chebyshev's inequality. In any distribution, the percent of observations falling within k standard deviations of the mean is at least 100 times 1 minus 1 over k squared. So, Chebyshev's inequality, yeah, I know it's a weird one, but it actually gets at the idea of a normal distribution fairly quickly and easily without you having to go through too much time and energy, right? So it's a pretty straightforward formula, and also something that you could conceivably store into your calculator. Let's go through it first, and then I'll show you how to store it in your calculator. Because this is one of those ancillary topics where it's not going to seem like it's a valuable thing for you to learn about, and then there'll be one question on the AP where you're like, dang, I really wish I knew that Chebyshev's inequality, because it's not really that difficult. I could have totally got that one right, and now I'm not going to get it right. All right, so it's just straight calculation. The good news is we know how to manipulate a table. My battery seems to be getting low. So I have to go out to 5 standard deviations. So I'm going to type the number with 1, 2, 3, 4, 5. Oh, I hit second down a bunch of times. My battery's just fine, actually. I manipulated the contrast on my screen. It was throwing me for a loop. So I'm going to go on to L2, hit enter, type in 100, then 1 minus L1 squared, order of operations, 1 minus 1 over L1 squared. Order of operations will make the exponent happen before the division, so I don't have to worry about parentheses. Although if you're nervous about that sort of thing, like I very frequently am, go ahead and put it in. Yeah, the fraction toolbar doesn't, the fraction tool doesn't really work in this format. All right. So when you do that, you can get, when you hit enter, you get all of your percentages, and you just go right on down the line. That's not what I meant when I said we'll store this in the calculator, because storing it in the calculator shouldn't be something like, okay, remember the formula so that you could type it in an editor. I'll show you what I mean in a minute. So 0, at least 0% of the data would be within 1 standard deviation of the mean. I agree with that. Yeah, you should have at least 0% of the data. At least 75% would fall within 2 standard deviations. The empirical rule says 95%. 95 is at least 75%, so check. 88.8 repeated. Within 3 standard deviations, well, empirical rule says 99.7, which is definitely at least 88.8. Then 93 and 3/4. Empirical rule doesn't say anything about 4 standard deviations or 5 standard deviations, so we're in uncharted territory. So Chebyshev is actually giving us something more than the empirical rule would give us, so that's nice. And then 96 within 5 standard deviations. All right. Now, honestly, I would say that 4 and 5 are like, Chebyshev seems to be kind of like beating a dead horse here, because I don't know that we needed this information, because if we know in the normal distribution based off the empirical rule that about 99.7% of the data is going to fall within that interval, and if I go out to 4 standard deviations, then I don't need to know the number to know that it's damn near 1, right? 100% of the data, all right? Whatever it is, it's more than 99.7, and there isn't much more than 99.7 to go, so it's pretty much 1 at that point, all right? Because that normal curve is asymptotic with the x-axis, it's practically on top of it once you get past 3 standard deviations. All right. So now the moment you've all been waiting for. The moment where you learn how to program or create a program in your calculator all by yourselves. And it's one of those things, like if you're taking other math classes, if you're taking a science class that's formula based, like a physics class, not only, because there's so many people that do these fugazi like programs in their calculators that don't do anything, it really just aggravates me, because like you'll think I'm judging you for having the program that stores all the formulas in there, but I'm not judging you for that. I'm judging you for putting formulas in your calculator that don't actually do math for you. All right. What's the point of creating a program to put in, like, let's say, I'll keep it simple, the quadratic formula, if you're not actually going to have it do the quadratic formula for you? Come on, you know, like, put the formula in and then have it do the math. Come on, get with it, you know? So that's what we're going to do here. Like, we're going to put Chebyshev's inequality in there so that when you see it on a test, you're like, oh, what's that formula again? Oh, there it is in my program. And oh, by the way, I can run the program and it's going to do the problem for me. Thank you, Mr. Kankis, you're the best. All right, so program. I'll walk you through it verbally, and then later on, when I have a little time on my hands, I'll record a video. And then hopefully you'll, I took the sign down, but you'll smash that thumbs up icon. All right, that like button. So we're going to create a new program. So you want to scroll right to the word new. Now, you only have so many characters to work with here. So you're not going to be able to type in Chebyshev's inequality, but you can type in Cheb. You could go Chebby, I think.
What's the limit on letters? Is it like
8.
8? Oh, we could do Chevy Sheet.
Now, just so you know, and you're not going to run into this problem now, but when you try to write a program on your own, when you name it, the minute you hit enter, that title, that name is locked for editing. So you can't change that title without rewriting the program. All right? There's a workaround, and so what that is it's annoying. It's doable, but what it means is that you create a new program with the appropriate title, and then you run the previous program as a subroutine in the new program, and then delete the original program. All right, so it's extra steps, doable. You don't want to do it. Personally, if I see a title that I know is slightly off, it just aggravates me to no end.
When you clear the calculator, do the programs also get cleared, or they just stay there?
Programs get wiped out completely. All right, so do not clear your calculator under any circumstances. All right, that shouldn't happen in your calculus classes, and that shouldn't happen here. I can't speak for science. All right. So I need it to do this for me. All right. So if you called it Chevy, then you already know what it's supposed to do. So you don't have to give a little. Some programs have a little brief description of like what it's used for. If you came to the program to begin with, you know what it's used for. All right. So what you want it to do is ask you for the value of k. All right. So what we're going to do is select program. It brings you, for some reason, when you're in the program editor, it brings you to a completely different menu. All right. We're going to go to I/O, input output. There's two ways to handle this. If it's just a simple variable without any kind of language associated with it, like if you don't want to tell the user what that value represents, then you could just select prompt. If you want to tell the person what the value represents because it's not obvious, then you would select input. All right. So in this case, again, along the same lines, if you're going to this program for Chebyshev's inequality, I would think it's because you already know what it's all about. You just want to use it. All right. So I'm going to go for prompt, and I'm going to have it prompt the letter K. So alpha, open paren. And then hit enter. There's no save button here, so when you hit enter, it locks it in as a line of code, and then once you quit out of here and run the program, it'll work. Never hit clear when you're in this editor, otherwise it's going to wipe out an entire line of code, and if it was a substantial line, you're going to be kicking yourself. All right, now I'm going to plug that in, that rule. So I'm going to type in paren 100 close paren, although you don't need the parens on the 100, but I put it in because, you know, typo there becomes a typo here, so who cares? 1 minus 1 divided by k squared, so alpha open paren squared. Now, if I hit enter at this point, so don't hit enter. If I hit enter at this point and then run the program, it would ask me what the k value is, and then it would say done. I would tell it, I hit enter, it would say done. Because I told it to do this calculation, but the calculator is very literal minded. So it's one of those things like, if I were to say, figure out what 3 times 2 is, and then after that get upset that you didn't tell me the answer, you might say, well, you told me to figure it out, you didn't tell me to tell you the answer. right? It's kind of like a wise ass response, but the calculator is very much a wise ass, all right? So we did not tell it to tell us the answer. So that's the next step. So we're going to store this in as a dummy variable, all right? So choose any letter that's not already used in your program. A is available, and store it in as A. So the STO with the sideways arrow is your store key, right? It doesn't look like the button when you hit it. It just brings up a sideways arrow. So that's a little annoying, but it is what it is, right? As Mr. McCallie would say. So hit enter. Now that's locked in. Still have not told it to tell me the answer. All right, so I've told it to store it in as the value A. Now, if I have the wherewithal to hit the letter A on my home screen, it'll tell me the answer. But I wanted to do it as part of the program. So program, we did the input, so let's do the output. Display, option 3. Now, here what we can do is we could actually write a little blurb describing what the answer represents. But again, if you're going into this program because you want to use Chebyshev's inequality, it's probably because you have a sense of what that program is giving as a result. So maybe you don't need to do that. But let me just walk you through how you would do that. So, and I'll just keep it simple. I'll just say like answer equals. You would select quote. So that actually is a quote. It's just in trig. It also means seconds. So degrees, minutes, seconds. I'll type answer A and S.
The quote is plus sign.
The plus sign, yeah, sorry about that. Alpha plus, end quote. So that's you inputting it as a string of values that have no numerical representation. All right? Because if I just write A and S, it's going to think I want to multiply whatever A is equal to by whatever N is equal to by whatever S is equal to. All right? Comma. Now I want it to report my A. But you didn't have to do the answer part. All right? You could just say display A and it'll do the job for you. All right? And in retrospect, probably should have like a colon or an equal sign in there. So let me insert second delete. I'll just chuck a little colon in there. Alpha decimal point. Make it look a little nicer. All right, hit enter to lock that in. It doesn't matter if you have a colon with a blank line. It doesn't impact anything. And in fact, in your last line of code, you don't even have to hit enter and it'll still accept it. So once you have all that, quit, second mode. Go back into your program. Key, hit Chevy, under execute now, not edit, not new. Enter. That's calling up the program. Enter again activates it. So it says, hey, what's the K value? I'm going to put a 1, and it's going to tell me the value is 0. All right, run it again by hitting enter. I'm going to put in a 2, 75. All right, so now you have Chebyshev in there. You have the formula, and you have the formula doing work for you. Think about how you could use that in another class. Science class, all those formulas. Think about it. Should be pretty